Hi, this video is going to investigate a famous math problem that involves Gauss. Little Gauss was in the third grade or so, and he was a nuisance to his math teacher as he was very, very good at doing all the problems he was given. And to keep little Gauss preoccupied, Gauss's teacher gave him the following problem. Add up all the numbers from 1 to 100 that are integers. And this was before the days of calculators, so the teacher thought, wow, this will keep little Gauss busy. Unfortunately, little Gauss was able to answer this question under 30 seconds. He came up with the answer 5050, and I'm not going to tell you how he did that. You may already know. There might be a strategy to calculate that sum very, very quickly. I'll let you think about that and maybe Google it to see what you can find. What we're going to look at today is how we could write a computer program to answer this problem. So to get started, anytime we need to add up a bunch of values, we should be thinking we need a variable. And a good name is usually like sum, which represents an accumulation of values. And we'll give it the initial value of 0. And the kind of first try at this is doing something like sum plus equals 1, sum plus equals 2, sum plus equals 3, sum plus equals 4. And then we just have to do that all the way up to 100. Now that sounds like a lot of work to me. So we're going to try to do this in a slightly different way that'll be a little bit faster. So I'm going to comment out this first kind of attempt to start. And what we are going to do is introduce another variable here that I'm going to make equal to 1 to start. Now instead of doing sum plus equals 1, I could now write sum plus equals n, and that would do the exact same thing. I'm now increasing the sum variable by 1. If I was then to increase the n variable by 1, n will now hold a value of 2. So if I run it sum plus equals, and again, this second command will increase sum by 2. So if I do n plus plus one more time, now n will be 3. So sum plus equals n would be adding 3 to the sum. And what you should be seeing here is that this is a really repetitive pattern. And what computers are really good at is if you can write a pattern that does the same thing over and over again, we can model it very efficiently. And so here's how we're going to write this code in a very efficient manner. So we're going to create a loop that starts at n equal to 1. And our n that we're adding into the sum should not exceed 100. So we're going to keep it 100 or below. And then we're going to increase the value of n by 1 for each iteration. And what the command we're repeating on each iteration is we're increasing the sum by the value of n. So as n is 1, we're adding 1 into the sum. When n is 2, it adds 2 into the sum. And if we print out our answer here, hopefully we'll see the value 5050. And I run it. And I'll drag this up here so you can see that. And it appears we do get the value 5050. So to kind of summarize this in short, without the comments now, what we've got here is we've got a sum variable that we established as 0 to begin. We wrote a loop that ran the number of times we wanted, and we increased the sum, in this case by that positional variable. And by the end of the loop, we would have added up all the numbers from 1 to 100, and so the sum variable would have the answer we're looking for. I hope this made a lot of sense.